All right, so this is officially Chapter 11, Section 1, or you can call it 11.1. And our goal is just to focus on area. And I know there's different ways to represent this. What I would like you guys to think of is I'm going to make reference to the formulas the way our book does it, because our homework is going to be out of the textbook. So I just want to make sure that you guys are kind of getting the exact same notation. All right, so when we talk about a square has a side length of s. And we know all the properties of a square, right? It's got 4 congruent sides. So the area formula for a square is side length squared. And yes, you could do length times width. That will get you the same answer. But you're going to see it will be to your benefit to, when you're doing the area of a square, to call it side length squared. Okay? A rectangle, a lot of people call it length times width. Our textbook refers to it as base times height. And we do have to talk about this word height, because height actually is present in kind of all of these shapes. When we refer to height, height is the 90-degree or perpendicular length to the base. All right, so the area of our rectangle is base times height. That will give us the amount of space that a rectangle takes up. A parallelogram is actually just a rectangle that if I was to push along this side, just the top, and it tilted, it would turn into a parallelogram. Well, that thought process kind of gives me the same idea. The problem is I don't have a height, right? I don't have a 90-degree angle, so that height has to be present somewhere. And they usually use a dotted line with a 90-degree angle to represent the height. So then I'm going to do this in a different color. The area of a parallelogram is the base times the height, and the height is indicated to show the perpendicular distance between the bases. Right? Now, I do want to mention just briefly that the height doesn't have to be indicated inside of the shape. Right? I could drop a dotted line and then extend this line and indicate it with a 90-degree angle, and you could also show the height here. So I'll erase this just so you don't get too confused. There's only one height, but this blue height is the same as this red height, and it doesn't matter which one is present. It's just your base times your height. Okay? Well, then a triangle, what if I'm going to erase this too, but what if I cut this rectangle right in half? Okay? And I took just this side right here. Well, this triangle is exactly 1/2 the area of the rectangle. So a triangle will have a base, it will have a height, and its area formula is 1/2 base times height. Okay, so hopefully those are all familiar. There are 3 total triangles because we have the right, acute, and obtuse. And each one, it still has the same formula, but we have to indicate the height is indicated a little differently. In a right triangle, the height is actually one of the sides. In an acute triangle, the height is the distance from the vertex to the base. So in this case, we didn't really explore this yet, but it's called the altitude, which is the height of the triangle. And now in this case, the base here is, well, I could call this one the base, but then the height would have to be indicated from the tallest point in a perpendicular distance down to the base. So notice how the height is actually not part of the triangle and it's outside of it. And here the height is not part of the actual triangle, but it's inside, and they're indicated with those dotted lines. So just be aware of that. The big thing is you are going to want to really commit to memory the area formulas for those 4 shapes. One of the things I recommend is to make a flashcard. On the front side, put the word square. On the back side, put the area formula for the square. And then rectangle, triangles, and parallelograms. We're going to learn all those shapes that we learned in chapter 8 right before winter break. We're going to learn the area formulas for them. So it's going to become a lot. And the nice thing is they really kind of all are based off of the area of a parallelogram, base times height. Right? All of these are some form of base times height. The triangle is just half of a rectangle, so that's why it's 1/2 base times height. So if you can realize how they're related, it kind of helps. Okay, so we know that you want to make sure you have these formulas memorized, and you can use them at any point. I really love this quote from Nelson Mandela. I never lose. I either win or I learn. And they always say you learn more from your mistakes, which is why we offer remediation on tests. You can go back and keep taking correct them and get some points back. And I hope that even if you got 1 point wrong on the test, you're going back to look at it and understand why. And if you don't know why, you're seeking out help from me or a friend. All right, so our goal today is area, and we're going to talk about both perimeter and area of quadrilaterals and triangles today. Now, I don't want you to write these items here. We already have them, and they were in our notes. And that's kind of, I tried to do the warm-up today to save us time. So we already have this. I'm going to fill them out just for my note purposes, but I, again, don't want you to write it. So area of a square, we're going to consider it side length squared. Instead of base times height or length times width, since all four sides are congruent, and each side is considered s times s is s squared. All right, for a rectangle, it's just the base times the height. Now, do keep in mind, base does not always refer to the word bottom, right? And I'll show that with the next slide. But the area of any rectangle, we know, or we saw earlier, was base times height. I don't want you to write these. These are kind of common sense pieces. It's called the area congruence postulate. So what if I tell you I have two shapes? And these two shapes are congruent by side, side, side. Oops. All right. Because we know what the word congruent means, they're exactly the same in every single way. What do you think about their areas? If the triangles are exactly the same, then their areas have to be the same. So if two polygons are congruent, then their areas are congruent as well. Kind of a common sense piece because we really know what congruence is. The next part is called the area addition postulate. And all that means is if I have different shapes, I can add those different shapes together to get a larger area. So if I was to draw a picture that looked like this, right? Now we don't know how to find the area of a pentagon yet, but I hope you don't think of this as a pentagon. I hope you think of it as finding the area of the triangle, the first shape, and the area of the rectangle. So the area of shape 1 plus the area of shape 2 would equal the total area. And we're going to do a couple problems like this. That's why I didn't want you to write this down. But it's basically you're finding the sum of all the non-overlapping parts and adding them together to get the total area. All right, and then I like this one. Again, we have these already, so we're not going to write them down. But the area of a parallelogram is the base times the height. I want to show you, here's the base, here's the height. A quick visual as to why. Why is the area base times height? So what if I took this triangle right here and I cut it off? I took a scissor and I cut it out, and then I slid that triangle over here. So now this triangle's gone. What shape is it? It's a rectangle. So the area of a parallelogram is the same as the area of a rectangle. The only thing we have to be aware of is how do we indicate that height. And this was just a visualization piece that I could just cut this and turn it into a rectangle. Okay, and then same thing with a triangle. What if I took this triangle? I'm going to see if this works. What if I took this and I flipped it just like that, and then I matched it here? Well, what shape did I just create? I created a rectangle, but I only want half of that, right? So half of the area of a rectangle is the area of a triangle. And that's where my brain thinks, okay, if I had base times height, but then I cut that in half, that's the area of the triangle. Now, I will mention a lot of students are used to saying base times height divided by 2. Both of these are the same. They're equivalent. You can use either one. I would prefer this one. And the reason why is if I give you the area and we're working backwards, students do better with the 1/2 written this way versus the divide by 2. But it doesn't matter, whichever you're comfortable with. And then as we talked about, if I called the bottom the base in this specific case, then its height would be indicated by the perpendicular distance from the tallest point straight down to the base. Okay, so I would like you don't have to write this one down unless you want to. I'm going to put up a Zoom poll in a second, and I want you to tell me what is the area of the triangle that's provided. Okay, so give me a second while I get my Zoom poll up, and then we'll see your response. Okay, if you're watching the video, hit pause, try this problem, and then just think of this as a multiple choice question. Here's the way I would like you to approach this answer. What do we know? It's a triangle, right? I have to find the area of a triangle. So it's 1/2 base times height. Now, technically, the height is always indicated by the 90-degree angle, and the base is the length of the triangle itself. Now notice, the dotted line is not part of the triangle itself. So I know that the area is 1/2 the base times the height. The weird looking 19. So now the question becomes, what is the height? Well, 13 is not the height. The height is the distance from the tallest spot straight down at the perpendicular distance to where the base would be extended. So I need to find h. Well, this forms a right triangle, which means Pythagorean theorem. Or if you notice, 5 something 13, this is a triple. It's 5, 12, 13, so the height has to be 12 because of a Pythagorean triple. And then if you do 19 times 12, you get 228, and then I divide that by 2, and I get 114 millimeters squared. And this brings up another important concept that I want to make sure you're all aware of. Because I multiplied two quantities, I multiplied the base and the height, and they're both in millimeters, that would be like having millimeters times millimeters. So the units for area is millimeters squared. So please make sure any units we do for area, the units will always be squared. And there we go. So as you saw by the results here, this is a very common problem that students end up misinterpreting. It's mostly because of the height, but it's also because they want to include the 5 in the length of this triangle. And maybe I should have highlighted, and I didn't do this at the start, but when we say area of the triangle, this is the area that we covered. All right, so a couple people were asking questions about where did the 12 come from? Well, it didn't just appear out of nowhere. So let me show you just quickly. If I take the dotted lines and I just look at a quick little triangle here, right? This is 5, this is 13. I need to find this length right here, which I can call h, that's the height. Now, it is a triple, So if we go back to Pythagorean theorem, we know that it's going to satisfy the c squared equals a squared plus b squared. Now, if you didn't recognize that it was a triple, then you would have had to done this work. 13 squared is 169, subtract 25. The height squared is equal to 144, so the square root, that's where the 12 came from. So I just used the fact that it was a triple to kind of save time. So notice how we basically are always using Pythagorean theorem. It shows up in every unit. And I've actually met a math teacher before that said he would give $1 every day to the student that would basically say, hey, you didn't use Pythagorean theorem today. He would give them $1 if we didn't use it for that day. I don't know how he afforded that, but okay. Here's another problem. I'm going to pause the video. I'd like you to read this and do your best at this problem. We're going to go 2 minutes on it. My advice for you is draw a picture. Okay? See how far you can get, and then we'll go over it. Let's go over this one. The area of a triangle is 84 centimeters squared. You don't need a picture, but I'm a visual learner, so I'm just going to draw a picture, and I'm going to draw a picture that, I don't know, a lot of students try to sometimes draw right triangles. It really doesn't matter. But I'm going to draw a picture. It looks like this, and if I do that, I'll call the bottom the base for this case, and then the height is represented by the perpendicular distance from the base up to the highest point. So what do I know? I know right away from the first couple of words the area of a triangle. So I'm going to go ahead and just write out the area formula triangle is 1/2 base times height, but I know that area is 84 centimeters squared. And that's the tricky part, right? The base of the triangle is 6 times the height. Well, let's think of that. Do I know what the height is? No, I don't. So if I don't know that, I could leave it as h, or in math, if we don't know something, we usually call it x. So I'm going to call the height x. And then that means the base is 6 times that. So I'm going to call the base 6 times x. Now, I could have also wrote 6 times h and just left h as is. But some students, I think, do better when they just call it x. It's completely up to you. So what do we know? The base is 6 times whatever we said h was, and then the height is x. And there's the algebra problem. So now we can do some quick simplifying. Well, 6 times 1/2 is 3, and x times x is x squared. And then if I take and divide this out, 84 divided by 3 is 28. Equals x squared. Right, so divide by 3, and then I'm going to take the square root, and you'll notice we're going to go right back to some of that work that we had in earlier units. Now I have to reduce this radical, and I don't want any decimal answers, so I want to leave the radical as is. So the square root of 28, well, that can be broken down into the square root of 4 times the square root of 7. And remember, the square root of 4 is 2. Square root of 7 is exactly the way we want it. So we're going to leave it as 2 square roots of 7. Well, what does that mean? Well, now I have to find the base and the height. Okay? So the height is equal to x, and I know what x is, so my height is 2 square roots of 7. And then we do want to put the units. Since the area was in centimeters squared, that means the lengths, or the base and the height, are just regular centimeters. Well, my base ended up being 6 times that value. So for my base, I'm going to do 6 times whatever the height was. And then this is multiplying radicals. So the 6 and 2 are going to multiply together to give me 12. and then we leave the square roots of 7 as is. And then we're done. Okay. Now, let's say that this was a test question and you were semi-confident in it, but you just wanted to make sure. I could check my answer. And this is just a good review of multiplying. So what if I did the base times the height? So if I took the base of 12 square roots of 7 times the height of 2 square roots of 7 times 1/2. Well, here's kind of how my brain works. I'm going to multiply 1/2 by 12. Sorry, why wouldn't you square the answer? Not positive which answer we're talking about. If it's so we're going to leave the square root because those are the radicals, and the radical appeared. So I have x squared here, and then to get rid of that, I had to take the square root of both sides, and that square root and squared, they go away, right? So that's just x. And the square root of 28, no, the decimal answer, no decimal answers threw me off. Oh, so this just, remember our radical work? So radicals are more accurate than decimals, and that's why we don't do that. And so when we had the squared here, we had to get rid of the square to take the square root, and then we had to split this up. And remember the perfect square? So we have the numbers 1, 4, 9, 16, 25, 36, 49. We're looking for those perfect squares, and 4 was the largest perfect square that went into 28. So I just rewrote 28 as square root of 4 times square root of 7. And then that's square root of 4 is 2, and the square root of 7 can't be broken down. So, but now I have my answers, right? So I just want to check 1/2 base times height. Well, what if I do, there's a couple ways to think of this. What if I took the numbers here, the 12 and the 2? Those multiply together to give me 24, and half of that is 12. So I'd get 12 there, and then I get the square root of 7 times the square root of 7, which officially is the square root of 49. But the square root of 49 is 7, and 12 times 7 gives me 84 centimeters squared, which makes me happy because that's what the area was supposed to be. So you can use and check your work. You just have to really be comfortable with multiplying radicals. All right. Next problem, we're going to do these in kind of a shift. And I want to do the first one together for sure, because there's a special way I like to think of this problem. But I will give you a moment to just draw this picture really quick. Okay, here's how I would like you to kind of approach this problem. If I want to find the area first, I like to set up what's called a picture problem, all right, or a picture equation. So the area of the shaded region is really two things. It's the area of the big shape minus, what are we cutting out of it? I've got my blue shape that would be a parallelogram, but then I'm cutting out of it a right triangle. And I like to just draw this kind of in a nice form. So we have one of the legs is the bottom. And a lot of times, the students that take the time to draw this picture end up doing quite well with problems like this. So now we need a couple of things. Let's deal with this part right here. I need the area of this parallelogram, which is just the base times the height. I'm going to deal with that first, and then we'll end up subtracting the area of the triangle. Well, what is the base? That's not too horrible. The base is 14, right? That's the distance along this length. But the challenge is, what is the height? And remember, the height is the distance perpendicularly between the bases. Now, this height does not have to be drawn here either. So I could draw it on the outside, or as we're kind of noticing, see this length right here? This length, the hypotenuse of the triangle, is the exact same thing as the height for this parallelogram. So that's my goal, is I want to find this length right here. Now you'll notice we're kind of reviewing a lot of older topics, right? We did Pythagorean theorem on one example. Well, now I have a 45, 45, 90. We haven't done this in a long time. You hopefully know that because both of these are 45-degree angles, that these two legs are both 5 inches. And if you don't remember the shortcut for the 45, 45, 90, then you would have to do Pythagorean theorem to figure out this length for the hypotenuse of that triangle. However, if you do remember the theorem, remember this side length was n, and this side length was n, so its hypotenuse was n square root of 2. Well, that makes the length of the hypotenuse 5 square roots of 2. That's where this height is going to come in. And notice I didn't use decimals either. So if you were doing Pythagorean theorem, you would need to find your answer in radical form. All right, and then the nice thing about this problem is 14 times 5, that's 70, I believe. Let's see, 20, yeah, that's 70. And then we're going to leave the square root of 2. So 70 square roots of 2 is the area of all this blue shape. It's as if that triangle wasn't there. Right? Well, now we're going to do the area of the triangle. And the triangle, we know its formula is 1/2 base times height. And I should kind of put this in grouping symbols because whatever this answer is, we're going to subtract it from the area of the parallelogram. Well, 1/2 base times height. Well, wait a minute. I have my base could be considered 5, and my height, because of the 90-degree angle, is 5. So both the base and the height are 5s. All right, and then 5 times 5 is 25, half of 25. I'm going to leave it as 25 over 2. Now, technically, you could stop here, right? This isn't super friendly. This one has a radical, this one doesn't. And it's not super friendly. The only way I could match this is if I got the denominators both to be 2. So think of this. If I double 70, I get 140 over 2, right? And then the square root of 2 would come into play. But then since I would be subtracting 25 halves, the 25 could just be written on top like this. And this, again, I kind of showed you, this is not a super friendly answer. I would either stop here or here for my answer. And then it is inches squared because this is the shaded region. So that would be the blue region with the triangle cut out. All right, perimeter. Well, I'm going to actually move this one down below so we have room. All right, now I have to find the perimeter, and let's assume here they say the perimeter of the shaded region. So if I'm following this perimeter, let's assume that it's referring to the distance around all this gray walking path. So if this was a park, it would be all of those distances added together. So do, 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 do. You know what? We can't do that. We actually can't do this. I take that back because I don't know this length from here to here. And that's an error in my fault. So let's not do perimeter on this one, and we'll just have done area. This was not the best problem. We will do perimeter and area for the other one, though. All right, last problem here. I'm going to just put this on a separate. And take a look at this one here. So I'll give you a second to draw this picture. And why don't you work on this? Let's take a couple minutes, and I'll have you guys do it by yourself, and then we'll go over it in about 4 minutes. All right, so that was about 4 minutes. Let's take a look. I always like to deal with area first because a lot of times the items I need to find for area help me with perimeter. So if I think of this as one big solid shape, there's a couple of ways you can do it. And we technically don't know. We could cut it right here, but I don't know the area formula for a trapezoid yet. So I'm going to avoid using that. But what I can do is what if this was just a rectangle with a triangle cut out of it? Well, in that case, then I would want to set up the area. My picture equation would be the area of the rectangle minus the area of that little triangle cut right out of it. Right? So in this case, if I found and sometimes I'll put a T here for like total area. In this case, it's just the area, but the base times the height for this rectangle. Well, we know what the base is, we know what the height is, that's pretty quick, right? The full base is 12, and the full height is 5. So 5 times 12 is 60. And yes, you can cut this into multiple different sections. I'll share with you. This is just one way that I would do it. There are many different ways that you can approach this problem. So I found the area of if this was a big rectangle, and then I'm going to just find the cutoff piece and subtract the area of that triangle. And I know that the triangle is 1/2 base times height, so I need to figure out what is its base and what is its height. Well, this distance here plus 2 has to equal the same length here. So the only option for the height is 3. And then this distance from here to here, which is technically the base of the triangle, plus 8 has to equal 12. So 12 minus 8 is 4. And this is a 3, 4, 5 triangle. This is one of those special right triangles. Now, I don't need this length, but it's going to come up later in the perimeter, so that's why I mentioned that. So the base is 4, the height is 3, 4 times 3 is 12, 12 cut in half is 6, and my area is 54 units squared. Now notice, we didn't put inches, we didn't put centimeters, but they said units. Even if they didn't have the words units, you should still write units squared to indicate the total area. Okay, so you know what the units are. All right, and then my perimeter deals with knowing this length right here. Now, I'm not going to show this work, but you could do 3 squared plus 4 squared equals c squared and do the Pythagorean theorem, but it's a triple. 3, 4, the only possible answer is this has to be 5. So then perimeter ends up being all of these distance around the shape. And then if I add those together, that's, let's see, 20, 32 units. Okay, so a quick question came up. How did I get the 3 and the 4? Where did those come from? Think about this length here, right? This length from here to here is 5, all the way down, and it has to be the same. So if this full length has to be 5, then the 3 came from 5 minus 2. And then if this full length going left to right is 12, then I subtract 12 minus 8, and that's where the 4 came from. So that's how I got the 3 and the 4, and the 5 right here, that came from Pythagorean theorem. All right? So one of the things I hope you notice with these problems is it's more than us just doing one formula, right? Sometimes it's a composition of formulas. By the way, I do want to mention really quick, somebody brought up a good point. They said they divided this shape into 3 different regions. My guess is they might have done this. So if I divide this here, I got a rectangle up top, I've got a rectangle on bottom, and then I have a triangle here. And you could do this work the exact same way and find the area of these 3 pieces instead of doing it the way I did. So there are a lot of times there are multiple ways to do problems like this. And the way I do it might be different than the way you do it, which is completely fine as long as we end up at the same answer. All right, so here's what we got. Your homework tonight is, some of them are really quick. Just find the area problems. Some of them involve working backwards like we did, and then some of them involve the shaded regions. So I just want to make a quick point with 25 and 27. Notice in 27, something is being taken out of it. And for 25, we have 2 shapes that are composite or put together. So there's your homework tonight. I will be in my office hours from 1 to 2. If you need any help or have any questions or anything, those of you that need to get that test done, get it done. Those of you that need to work on missing homework, get that done as well. And then please submit the picture of your work for 11.1 to Schoology when you're done.